Another topic we have seen this year is the fundamental theorem of calculus. And this theorem links the concepts of derivative and the concept of the integral together in one theorem. So basically, the fundamental theorem adds up the areas of rectangles with area delta x times f of x, where delta x approaches 0. So basically, it adds up the areas of infinitely many rectangles between a given interval in a function. So as you can see in the illustration, if f of x is this function and the integral of from a to b of f of x equals the area beneath the curve of f of x from a to b. So as you can see, the fundamental theorem is used to find areas beneath curves, and it is helpful in many applications such as physics and countless other fields of study. But there's a condition. F of x has to be continuous on the closed interval ab and differentiable on the open interval ab. So the way to find the value of an integral is simple. Let's say that this is our integral. So the definite integral of f of x from a to b. So what you need to do first is find the indefinite integral of f of x. And let's say that in this case g prime of x equals f of x. Therefore, the indefinite integral of f of x is g of x. So what you need to do next is to find g of b, of the upper bound of the interval that you're evaluating, minus g of a, or the lower bound of the interval you're evaluating. And this value will give you the value of your definite integral. So this pretty much sums it up. The definite integral from a to b of f of x equals g of b minus g of a when g prime of x equals f of x. So now let's try a few exercises. So the first one, it is the definite integral of 2/3 x cubed plus x squared minus 1/3 x plus the square root of x from 4 to 12. So first you need to find the antiderivative of this function. So by doing it, you get 1/6 x fourth plus 1/3 x cubed minus 1/6 x squared plus 2/3 x to the power of 3/2 plus c. But we can assume that c is 0 to make it simple. So, and this will be done from 4 to 12. So what you need to do is plug in 4 for all the x's here and subtract from that value the value of this whole thing with x instead of with 12 instead of the x's. So in the end, after you do that, you get 66 2/3 minus 4035.7128. This is an approximate number, it's not exact. So basically, if you subtract this, the integral from 4 to 12 of 2/3 x cubed plus x squared minus 1/3 x plus the square root of x dx equals negative 3969.046. And even though the integral is negative, it is possible for there to be negative areas. It's just basically this. Let's say a function is this, and you're finding the integral from here to here. The area will be negative. So now we can try another example. This one is the definite integral of negative 5 sine of 2/3 x evaluated from 0 to pi halves. So this one is a bit trickier because you have an inside function, this one. So what you need to do is substitute it for a variable, for example u. So you get that u equals 2/3 x, and if you derive, you get that du equals 2/3 dx. So now you can plug in what you know. So the integral from 0 to pi halves negative 5 sine u times du times, well, because dx equals du times 3 halves, so you divide by 3, divide by 2. So now what you can do is you can isolate the constants here, negative 15 over 2, and put it outside the integral, because the integral of a function times a constant equals the constant times the integral of the function. So you get negative 15 over 2 and the integral. So now, as you can see, this part of the function only has the variable u. So what you can do is change the bounds of the integral to a value that corresponds to u. So let's say that x, you use this function, this equation. So if x equals 0, then u will equal 0. So this one stays unchanged. But now if x equals pi halves, then u would equal pi thirds. So now the integral becomes negative 15 over 2 times the integral from 0 to pi thirds of sine u du. And now you can find the integral without any problems using u as your new variable. So what you get is negative cosine u from 0 to pi thirds times 15 over 2. Now if you evaluate this, you get negative 15 over 2 times negative 0.5 plus 1. This gives you 1/2, so basically negative 15 over 2 times 1/2, and the answer would be negative 15 over 4. And that is the value of your definite integral. As a final example, we can do an application of the fundamental theorem of calculus. Let's say that the velocity of an F1 car in a championship race is modeled by a v of t equals 1/4 t of 4 to t to the power of 4 plus 1/10 t to the power of 3 plus 8t. T is in minutes, so we need to find the distance traveled during the first 15 minutes. So because velocity times time equals distance, you can find how much the car traveled by integrating that function. So basically the integral you need to find is this. The integral of 1/4 t to the power of 4 plus 1/10 t cubed plus 8t from 0 to 15. So as we already know, we need to find the antiderivative of the function. So that leaves us with negative 120. No, this is negative, sorry. This is negative 1/4 t, 2 to the power of 4. So the antiderivative would be negative 120 t to the power of 5 plus 140, 1 over 40 t to the power of 4 plus 4t squared plus c. We can take it 0 from 0 to 15. So if you plug in 0, you get 0, so 0 minus. And now if you plug in 15, you get negative 1 over 20, 15 to the power of 5, plus 1 over 40, 15 to the 4th, plus 415 squared. So if you simplify this, you end up with 0 minus 35,803.125. So the answer is 35,803.125 meters traveled during the first 15 minutes. I forgot to mention that this is in meters per second. So that would make this meters. If it were kilometers, kilometers per minute. Sorry. So yes, that would make this integral be 35,803.125 meters.